So here we are going to discuss the effect of inductive effect on acidic strength. So electron withdrawing groups basically increase acidic strength and electron donating group decrease acidic strength. So if a group has minus I effect, acidic character increases. If a group has plus I effect, acidic character decreases. Alright. So we have few examples out here. So if you check out in first example, as number of carbons is increasing, so if here you have methyl, then you have ethyl, then you have diethyl, and total carbons is 3. You have total carbons 3 and you have total carbons apart from carboxylic 4. So number of carbons plus I, if I see plus I in this one, plus I in this one, plus I in this one, and plus I in this one. So what is happening is plus I is increasing from plus I 1 is less than, plus I 2 is greater than, plus I 3 is more, and plus I 4 is more. So acidic strength is inverse of plus I. Acidic character is inverse of plus I. So from here you can see that fourth compound is least acidic and the first compound where plus I is not present is most acidic. So in greater the plus I effect and less will be the acidic character. So acidic character is highest in the first compound where plus I is least, and least acidic character in fourth or the last compound, fifth one, where we have plus I maximum. So there is inverse relation between plus I and acidic character. Similarly, if minus I is more, acidic character is more. That is what is happening in second example. What we have is, we have 3 chlorine atoms, we have 2 chlorine atoms, we have 1 chlorine atom, we have no chlorine atom over there. So minus I is maximum here and minus I is minimum here, and this one has plus I effect. So minus I is more, so acidic character is more, right? Minus I maximum, so acidic maximum, and as we go from right to left, minus I is decreasing, so acidic character is decreasing, and the last one has plus I, so it is the least acidic compound. So direct relation with minus I and inverse relation with plus I. That is what we have observed over here. And if you have multiple halogens, so fluorine will have the maximum minus I, then chlorine, then bromine, then iodine. So maximum minus I is for fluorine. So if you have trifluoroacetic acid and trichloroacetic acid, always trifluoroacetic acid will be more acidic than trichloroacetic acid. Alright. Next we have amines. So you can easily observe here that in ethyl, amine and ammonia, ethyl group has plus I. So what has happened is electron density on nitrogen is increased, whereas in ammonia electron density on nitrogen is not that much increased because there is no donating group. Here electron density on nitrogen is increased. So since acidic character is inversely proportional to plus I, it is inversely proportional to plus I and directly proportional to minus I, basic character has a direct relation with plus I. It is exactly opposite. It has direct relation to plus I and inverse relation to minus I. So from here you can observe that ethyl amine is more basic than normal ammonia, right? So amines are always more basic than ammonia. Acidic character is also related to Ka. So Ka directly proportional to acidic character, and if you have pK, so pK and acidic character have inverse relation, 1 by pK. So acidic character is inversely proportional to pK, and similarly basic character is related to Kb and inverse of pKb. For a better base you will have least pKb. Similarly for a better acid you will have least pKa. So minimum pKa, maximum acidic character. Similarly minimum pKb, maximum basic character. So these are few things which we need to understand for comparison of acidic and basic character. So that is it for now. Thank you.